The AI in your pocket started as a thought experiment written in 1950 by a man who never saw a computer with a screen. And the road from there to here is not the straight line you've been sold. It includes two complete collapses, decades where the phrase artificial intelligence was so toxic that researchers renamed their own field to keep their funding. It includes a breakthrough that arrived by accident on hardware built for video games. And the pattern in this story is repeating right now around you by the end. You'll see it clearly enough to judge what happens next. 1950 to 1956. It starts with Alan Turing. In 1950, he published a paper opening with the question everyone else was too embarrassed to take seriously. Can machines think? He immediately pointed out the question is badly formed because nobody agrees what thinking is. So he replaced it with something testable. Put a human and a machine behind a wall. Let a judge type questions to both. If the judge can't reliably tell which is which, then arguing about whether the machine really thinks is philosophy, not engineering, that's the Turing test. And the reframing mattered more than the test. Stop measuring the inside, measure the behavior. Modern AI benchmarks still work on that principle. 6 years later, a small group gathered at Dartmouth College for a summer workshop. Their proposal contained the sentence that named the field. They would study artificial intelligence. They believed a 2-month effort by 10 smart people could make significant progress on language, abstraction, and self-improvement. 2 months, 10 people, hold on to that because it's the first appearance of a habit. The field never broke. Brilliant people, correct about direction, catastrophically wrong about timing. 1960s to 70s. The early results were genuinely thrilling. Programs proved mathematical theorems, sometimes more elegantly than the textbook. One held simple conversations by reflecting your words back as questions, and people formed emotional attachments within minutes, which told us something uncomfortable about humans that we're relearning right now. Governments poured money in. Machine translation would make language barriers obsolete within a few years. Then it hit a wall. Programs that solved toy problems collapsed the moment you handed them the real world. Translation needs meaning, not dictionary swaps. And the machines were absurdly weak, less computing power in an entire research lab than you're holding right now. The reckoning came as official reviews saying essentially this field promises repeatedly and delivers rarely. Funding was cut hard, labs closed. That's the first AI winter. The lesson echoes straight into today. Hype is alone and reality always collects. 1980s, 90s. The 80s brought a comeback with a different strategy. If general intelligence is too hard, go narrow, sit with an expert, extract their knowledge as thousands of if-then rules, encode it. These were expert systems, and briefly, they were a billion-dollar industry. But rules don't bend. They were brittle, useless outside their rulebook, and monstrously expensive to maintain. Because every change in the world meant a human rewriting rules by hand. The market collapsed. AI winter number 2. This is the era where researchers started calling their work machine learning instead because AI killed grant applications. Then in 1997, something cut through the frost. IBM's Deep Blue defeated Garry Kasparov, the reigning world chess champion. A machine beat the best human mind at the game we used as our symbol of intelligence. But look at how Deep Blue evaluated around 200 million positions per second, guided by handcrafted rules from human grandmasters. It did not learn. It outcalculated a human the way a calculator out-arithmetics you. Impressive. And a dead end. The real revolution needed a completely different ingredient. 2012, that ingredient arrived in 2012 in an image recognition contest where progress had been grinding along at about a percentage point a year using handcrafted techniques. Then a team entered a deep neural network, an old idea from the 60s that had never worked well enough to matter, and beat the field by a margin so large people initially assumed a mistake. Three things had finally lined up: better training methods for deep networks, enormous labeled datasets, courtesy of an internet that had spent a decade quietly becoming the largest collection of human labeled data in history. And the beautiful accident graphics cards. GPUs were built to render video game explosions, which requires millions of parallel matrix operations. That is exactly what training a neural network requires. Gaming hardware turned out to be AI hardware. And the philosophical shift is what actually matters. Machines stopped following rules humans wrote and started learning patterns from examples. Nobody tells the system what a cat looks like. You show it cats. Every AI you use today descends from that moment. 2017 to 2022, deep learning conquered images fast. Language was harder because meaning depends on context, stretching across a paragraph, and models of that era read one word at a time and forgot the beginning. By the end, in 2017, researchers published a paper with a rockstar title, Attention is All You Need. It introduced the transformer. The core idea, stripped of maths instead of reading in order, let the model look at every word simultaneously and learn which words matter to which. And the trophy didn't fit in the suitcase because it was too big, it learns to connect it to trophy. That's attention, and because it processes in parallel rather than in sequence, you can train it on absurd amounts of text. That unlocked scale, and scale did something nobody fully predicted. Make the model bigger, feed it more, and capabilities appear that were never programmed and never targeted. Translation code, step-by-step reasoning. 5 years later, that architecture became a product. ChatGPT, 100 million users in about 2 months, the fastest adopted consumer technology in recorded history. Bad for a field declared dead twice. 2023, Toe Day. And now the chatbot era is already ending. Models stop being text only. They see images, hear speech, generate video, hold real-time voice conversations that happen in about 18 months. But the bigger shift is from answering to acting. Give a modern system a goal instead of a question, and it will browse, run code, use tools, check its own work, and take multi-step action on real computers. Not explain how to fix this bug, but fix it, test it, open the pull request. That's the agent era. And it's the largest change in what these systems are for since 2012. The measurement stopped being how good the answer sounds and started being whether the work got done. The pattern, 70 years, one cycle, over and over, breakthrough, wild extrapolation. Money floods in. Reality arrives late and smaller than promise. Money leaves, then years of quiet, unglamorous work by the people who stayed, which produces the next breakthrough. And here's what actually matters. Every winter was caused by a timing error, not a direction error. Machine translation did arrive 40 years late. Neural networks did work. Once we had the data and the chips, the dreams weren't wrong, the calendars were. So when someone tells you a capability is 5 years away, history says the capability is probably real and the 5 is probably fiction. We're currently in the biggest spring ever recorded. History doesn't tell you whether another winter comes. It does tell you the pattern has never broken and how to read the claims flying past you. Separate what the technology can do from when someone says it'll do it. If you could go back and bet on one decade, which would it be? The Dartmouth Optimist, the Expert System 80s, or 2012? Comment below. Hit the like and subscribe, because in the next episode, we are going to open the black box itself. What is actually inside a neural network? Simpler than you think, stranger than you expect.